Hello, today we are going to talk about the types of physical quantities. So the types of physical quantities. So physical quantities can be classified. What's the spelling of classified? Huh? Classified? Yeah, and in the whole series that I teach, please don't focus on the pronunciation or the language, because I'm not that good in English, and I'm trying, but I'm not that great. So, physical quantities can be classified into four types on the basis of some rules. On the basis of some rules. Um, so let's write what are they. Should I write them or should I not? Let's write them. I don't know. Let's write them. Will it fit? If it will fit, I'll write them. If it not, then I won't. Would you say this fits? I would say this fits. So the first one is dimensional variable. The second one is dimensionless variable. The next one is dimensional. It's very difficult for me to say dimension and dimensional. So even if I say dimension, understand what I'm trying to say. Dimensional constant and dimensionless constant. So these are the four things that we are going to talk about. So let's move it a little bit up so that I can make it a little bit more pretty. Okay, let's talk about the first one, which was dimensional variable. So the physical quantities, understand what I'm saying, which has dimension but does not have fixed value or dimensional variable. Okay, so let's think of an example. Let's think about something which has a dimension but we do not have a fixed value. Does force have a dimension? Yup. Is force always the same? Not really, because you can say 1 Newton, 2 Newton, 3 Newton, 4 Newton. Let's think about something else. Does work has a dimension? Yup. Is every work the same? Not really. It can be different. It can be 1 joule, 2 joule, 3 joule, and so on. Let's think of something else. Let's think of power. Does power always have to be the same? No. Does it have a dimension? Yup. Which means power can also be an example of this. So when writing example, I will write only a few of them. So let's write work, force, power, and others you can think. Try to think of 3 more, because there are a lot of dimensional variable. So think of 3 more. Pause the video and think of 3 more and write them in the comments. Okay, the next one is dimensionless variable. The name makes it pretty clear. So I'm just writing the definition for, I don't know why I'm writing the definition, to make it easier for you, I guess, but it's pretty clear from the name itself. The physical quantity which neither have dimension nor fixed value. So let's think about something which does not have dimension and does not have a fixed value. That might be a little hard to think for you because there are not a lot of, I mean, there are a lot, but not that much as of the first case. So let me give you an example you might know or you might not know. Does angle have a fixed value? No. Does angle have a unit? Yes, it has a unit. But does it have a dimension? Nope, it does not have a dimension. Let's think about something else. Specific gravity, relative density, strain, refractive index. Do they have dimension? No. Do they have a fixed value? No. If you think any of them have a fixed value, just look them up. See how many values can you find. So one thing that will make it much more easier for you to understand or find dimensional variable is basically whenever there is a ratio of where the dimension of the top portion and the bottom portion are same or both of them are dimensionless, it will lead to a dimensionless variable if it is a variable. So let's write examples. I'm gonna write a few examples. The first one is angle. The second one is specific gravity. It is also known as relative density. The next one is strain. And the next one is refractive index, etc. So when learning this lesson, it's not that important to understand what these terms mean, what the example terms mean. It's important to understand what the definition is or to understand what the definition is, but it's not that important to know what these terms mean, such as refractive index, strain, specific gravity, because as you go on reading, it will be very clear to you what they are. So the third one that we're going to talk about is dimensional constant. So pretty clear from the topic it seems, but let's write the definition. The physical quantity which have dimension and fixed value. So think of something that has a dimension but has a fixed value. Um, do you remember gravitational constant? Speed of light in vacuum? Do they have units? Yep, they have units. Does that mean they have dimension? Yep, that means they have dimension. And are they fixed values? Are they fixed values? Yeah, they are fixed values. So we can write gravitational constant another is speed of light in vacuum. Its symbol is C and it's approximately 3 into 10 to the power 8 meter per second. We will get to that when we get to speeds. I don't know if there's a chapter called speeds, but the speed of light in vacuum is pretty common, so we will get to know this pretty well. So the last one that we're going to talk about today is dimensionless constant. So pretty clear from the name itself, but let's write about it anyway. Why not? Because we are gangsters, aren't we? Yep. The physical quantity which does not possess a dimension but has a fixed value. Okay, let's think about something that does not have a dimension but has a fixed value. So it's actually pretty easy examples if you think about it, but you just might not know it. Wanna hear? What are they? Have you heard of pi? 3.14 da, 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 da. So approximately 3.14. That's that's a value, fixed value. I mean, we don't know all the values of it, but it's a fixed value. We don't know all the terms of it, but it's a fixed value, and it's a number, so it does not have a dimension as well, and it also does not have a unit. So another one, which you might have heard, the pi. I'm pretty certain that you have heard of it. But and the next one is Euler's number, which is represented by small e. Its value is 2.7. Da, 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 da. It also has a lot of digits. We don't know all of them, and it's also a number, so it does not have a dimension, does not have a unit, and is a fixed value. Pretty cool, right? So that was it for today. In the next video, we are going to talk about the application of dimensional analysis, and we are gonna I don't know, we will see what we'll do in the next video. So we are going to talk about the dimensional analysis in the next video. Stay tuned for that. Thank you.